Okay. Now, this one, the funny thing about it is, it looks like a good problem for the ratio test. So let's try that. And of course, this would be n squared, the natural log of n. And this, we could write this as a natural log of n plus 1, natural log of n times n plus 1, like that, squared. Trying to get some simplifications here. This n over n plus 1, this is 1 to minus 1 here. So this is natural log of n plus 1, and then times 1 minus 1 over n plus 1 squared. Okay, so you still have, even after that, you still have infinity over infinity here, and this is 1 minus 0, so that's just going to be 1 squared. So we have to concentrate on finding this limit. What happens to the, and by the way, this is the, I won't say that that's R, because R is the limit, so I haven't found the limit yet. But we're going to concentrate on that limit, so we're going to find this limit for this form here. Natural log of n. This part we already know is just going to head to 1, so it shouldn't affect what we do over here. It's a product of the two limits. Now this one, we will use L'Hopital's rule on it. So we'll have 1 over n plus 1, and down here we'll have 1 over n. So that's this. Which equals a 1. The test fails. So we did all that work, and the test failed. So it doesn't mean anything except we have to do something else. So I would say I want to try something like this. Natural log of n is actually less than or equal to the square root of n. Now that itself is, you'd have to establish that if you weren't so sure. But if you look at the graph, you might have a hint. Here's natural log, here's square root. So the question is, do they ever meet? And you could, how could you verify that? Well, you could assume that they do and then show that that's impossible. Assume that, say, natural log of x equals square root of x. Assume that that's true for some x and then show that that's impossible. That'd be a way to do it. If this were true, then there would have to be a 0 for this function. And if there were 0 for this function, then it'd have to be over here somewhere. The difference between these two functions, it would have to occur over here somewhere. So if we're subtracting this function, someplace over here. So you could then try to find that or show that it doesn't exist. So that's the question. But we're not going to spend a lot of time. We're going to assume that this is okay, that this is true, that these never meet. And then, but if you're uncomfortable with that, then you'll have to actually show. You'll have to take a little more effort into establishing that this never actually happens. Natural log of x minus root x equals 0. So there's a couple ways you can go about that. Like I said, let's see, this is minus root x. So down in here, I would say that, that function, without actually graphing it, would have to look something like this. If it crossed, then there's be a number here. If it doesn't cross, oops, then since these are both negative numbers here, and here, it actually be negative in here, and at some point, maybe continue down. So that would be the assumption. Okay, so if there is a 0, it's going to cross, but if it's not, then you're going to have something like this. So there would have to be a maximum there. So you'd have to show that, but in any case, I'm not going to go into all that detail. We're going to start with this. If this is true, then this is true. And this is just this, which is convergent. In other words, this is the general term of a convergent series. So our series here is less than or equal to a convergent series by the direct comparison. Direct comparison, it must converge. Okay. So again, I kind of roughed this out here. I didn't really go into all the detail of it, but like I said, there's a couple ways you could try to determine if this ever happens or not, or you could assume that it does happen. So here I'm assuming that this happens, which implies this, which implies there's a 0, and you'd have to show that that 0 actually doesn't exist. If there's a 0, then it crosses like this. It comes up and crosses. Okay, but if you find the derivative of this function, you're going to see that that doesn't happen. Okay, you can show that possibly that it has a maximum, and then it won't actually cross there. So the derivative of that is 1 over x minus 1 over 2 root x. Okay, that's your derivative, and then that is 2 minus root x over 2x, like that. Okay, so this has a maximum, or a critical number at 4. Okay, and at 4, the function value is natural log of 4 minus 2, which I believe is negative. Natural log of 4 minus 2. Let me see what that is. That's negative 0.6. So I notice it's very rough in here, but you can always play back to listen to what I said. But that value would be y equals negative 0.6. So there's a point here actually at 4, but it's below the x-axis, so it's down here. So if it's coming up like that, then the only other thing left to be would be show that is in fact a maximum, as we suspect it is. And you could notice this is the derivative. As if x is bigger than 4, then this is bigger than 2, so it's negative when you get past. So it is decreasing over here and increasing here. So this is going to be what the function looks like. And it's only got one critical number, so it never is going to have a chance to come up and become 0 again. So will it ever be 0? No. In other words, these two functions are never equal. fact is the function is always negative, which means that the natural log of x is less than square root of x. So all that just to be able to say this right here. Anyway, so this one was kind of hard in that sense. And the other thing was I tried to use the ratio test on it, and it failed. I also tried to use a limit comparison, and I was thinking that if it converged, I should compare it to, say, 1 over n squared. But the problem with that is when I did that, I compared it with 1 over n squared, I got this, and that headed to infinity, so that doesn't really tell me anything. Okay, I'm comparing with a convergent series, and this is heading to infinity, so that doesn't give me what I want. I need to, in the comparison test, I need it to be a finite number, and then I could say both series behave the same way if I get a finite number, but this heads to infinity, so that this does not help me. So anyway, so this is the route that actually worked, taking this approach. So anyway, that was an interesting twist to that one. Okay. Well, all right, here's next problem. You might suspect, since that numerator is kind of large, exponential, that this thing would diverge. So first thing, if you suspect that, maybe this limit will help us. If we can show that this doesn't go to 0, then we can say it's divergent. So you don't need to use this heads to infinity, and so does this. So you can use L'Hopital's rule. One more time, because this obviously is infinity over infinity again. So we'll have natural log of 2, another natural log of 2, and a 2 to the n over an 8. Now you can see that does head to infinity. So not 0. Therefore, divergent nth term test. And then there's one more here. Okay, now this one, I'm not going to use the root test because I've got factorials here and I don't have any other n's besides this nth power here. So I'm just going to use a ratio test. So we're going to format a sub n plus 1 over a sub n. That's n plus 1, 7, the n plus 1, plus 1 factorial, and then that would be times n factorial, and 7 to the n. Okay, a little bit of algebra here is going to leave us with a 7. This is factorial down here, so I'm going to write that as n plus 1, and I'll do a little expanding here. Like that, and then we still have an n over here. So that's going to give us now just 7 over n. So that reduced nicely. And now when you take that limit, r will be equal to that limit. We do get to 0, which is less than 1, so we have convergence by ratio tests. Okay.